Today is day 16 of Advent of Cyber, and today's challenge is called SQL Injection is the King, the Carolers Sing. Set to have all their apps secured, the elves turn towards the one Santa uses to manage the present deliveries for Christmas. Elf McSkitty asked Elf Exploit and Elf Admin to assist you in clearing the application from SQL injections. When presented with the app's code, both elves looked a bit shocked, as none of them knew how to make any sense of it, let alone fix it. "We used to have an elf McCode, but he founded a startup and he helps us no more," said Admin. After a bit of talk, it was decided. The elves returned carrying a pointy hat and appointed you as the new elf McCode. Congratulations on your promotion. So it wants us to deploy the machine for this challenge, so I'll do that and I'll be right back. Okay, let's continue. SQL Refresher. SQL is the traditional language used to ask databases for information. When you build an application that relies on a database, the app will need to create SQL sentences on the fly and send them to the database engine to retrieve the required information for your app to work. Luckily for you, SQL was built with this simplicity in mind, and its syntax is supposed to resemble straightforward English sentences to make it easier for programs to understand. But before explaining the SQL syntax, let's talk about the specific database engine used on our app, MySQL. MySQL stores information in structures called tables. Think of them as any table in a spreadsheet document, where you have columns and rows. For clarity, let's check out one of the tables in the current application where the toys are stored. So as you can see, each row of the table corresponds to a different toy, and each column is a field of data that describes the toy. Looking at the third row, we can see that our toy tables contains a toy named Car, and that there are 12 units available for it. Pretty easy. As mentioned before, when an app needs to retrieve information from the database, it will need to build a SQL query. Queries are simple instructions that ask for specific data in a structured way that the database can understand. To query information, we'll use the select statement, indicating which rows of which table we want to retrieve. If we want to get all the columns from the toys in our database, we can use the following statement. Select asterisk from toys. Notice the asterisk, which indicates how you want to retrieve all columns from the table. If you need to ask for specific columns, you can replace the asterisk with a comma-separated list of columns. For example, to retrieve only the name and quantity columns, you can issue the following SQL query. Select name, quantities from toys. All table rows are returned in both cases before, but you can filter those if needed using a where clause. Suppose you want to filter the results of the last query so that you only get the toys for which there is at least quantity of 20. You could do so with the following statement. Select name and quantity from toys where quantity is greater or equal to 20. In real-world apps, you're likely to find much more complex queries in some cases, but what we've covered so far should be enough for the rest of the room. Sending SQL queries from PHP. Now that we understand how a select statement works, let's see how a PHP application builds and sends such a query to MySQL. Although we are focusing on PHP and MySQL, the same idea generally applies to all programming languages. The first step is always to get a connection to the database from our code. To do so, PHP includes a MySQLi extension, which provides the MySQLi_connect function. The function receives the IP or name of the database server as a first parameter, followed by the username and password, and finally the name of the schema to use, which is just an identifier of the database to which we are connecting. As a result, the function returns a connection handler, which we can use to send further SQL queries. Think of the connection handler as a variable that holds the connection information to the database, so that queries can be sent to it. So you got the server name, username, password, and the schema. Once a connection is made, we can make SQL queries using the MySQLi_query function. The first parameter we pass is the connection handler we got before, and the second parameter is a string with our SQL query. As a result of executing the query, we obtain an SQL result set and store it in the variable in our example. A result set is nothing more than an object that contains the results of our query, which can be used in the rest of our program to access the resulting data. As you can see, it is all as easy as building a string with our query and sending it to the database. Building dynamic websites. Now here's where things get interesting. If you check Santa's website, you can access an elf's profile by using a URL like this. Depending on the number you put in the ID parameter of the URL, you get served the profile of a different elf. Behind the curtain, this works by creating an SQL query that embeds the ID parameter value and returns the information on the corresponding elf. In code, it would look like this. You have the query, and then you're embedding from the GET request the parameter ID, where ID equals the number that's passed. The first line builds an SQL query by concatenating the GET ID variable as part of the where clause. Note that in PHP, you can access any parameter in the URL as $_get and the name of the parameter. This query will ask the database for all columns of the table users that correspond to the elf with a specific ID. The second line sends a query and returns the information of one particular elf as a result set that we store in the elves_rs variable. The rest of the website then passes the results set and renders the page accordingly. If you test the website, you can see that it works as expected. You have, however, introduced an SQL injection vulnerability in your code that could allow an attacker to dump your whole database. The problem with the method above shown before is that it takes untrusted input from the user and concatenates it to an SQL query without any questions asked. As seen in the previous day's task, our app should thoroughly validate any input the user sends before sending it. If it doesn't, unexpected things may happen. In this case of SQL, in our example, an attacker can send SQL syntax through one of the various parameters of the app's URLs, which might end up being concatenated to some SQL query in code, potentially changing its intended purpose. Let's get back to the Elves profile page to understand this better. Remember, the application is creating a query by concatenating whatever is sent to it, the ID parameter. Remember, the application is creating a query by concatenating whatever is sent in the ID parameter as part of the where clause. If the attacker sends the following through the ID parameter of the URL, ID equals -1 or ID equals 4, when PHP concatenates -1 or ID equals 4 to a SQL statement, it will end up with this query. Select everything from users where ID equals -4 or ID equals 4. Suddenly, the attacker has injected some SQL syntax that, when concatenated to our original query, ends up serving the data of the alpha of ID 4 for some weird reason. If we read the resulting query string, we can see that our where clause was modified to filter only the elves that either have ID equals -1 or ID equals 4. Since the ID values used by the database are likely all positive numbers, no elf will match -1. Therefore, the database will only return the elf of ID 4. While this example shows a harmless injection, a skilled attacker can try to get to your server to run much more complex SQL queries and potentially force the database to return any data on any table they want. Just an example, look at what happens when you put the following in the ID parameter. So ID equals -1, union all, select null, username, password, null from users. The SQL injection will make the database return all the users and passwords of the application. Santa won't like this for sure. If you're interested in learning more about SQL injections from an attacker's perspective, there is an SQL injection room on TryAcme. Fixing the app with elf exploit and elf admin. Armed with all this knowledge, we're ready to fix the app. You'll have access to a simple editor to modify this app's source code during this task. Any changes you make in the editor will go live instantly as long as you save your changes. If you are using the VPN connection, you can access the code editor from any browser of your preference. If you use the attack box instead, Firefox is installed and available on the machine's desktop. To get to the code editor, point your browser to the following address. Okay, so I've accessed the website from the challenges box, so let's get started. To enter the code editor, use the following credentials: coder and coder. Okay, coder. Okay, we're in, so let's see what's next. In addition to the code editor, you'll have access to a chat to communicate with elf exploit and elf admin. While they don't speak too much, you can request them to check the application for you. If you remember correctly, they don't know a thing about coding. However, elf exploit will help you identify parts of the app that are vulnerable to SQL injection. Elf admin, on the other hand, will check that the application is running as expected. So if you make a change that breaks the application somehow, he'll let you know so you can roll back and try again. In combination, they will tell you if your changes solve vulnerabilities while avoiding altering how the app is supposed to work. So to ask the elves to do a recheck on the app, scroll down the elf chat to find run checks button. So let's take a look in here. Let's do run checks. So yep, it's doing SQL injection there, as we can see. So let's continue reading on. One of the easiest and most effective ways to prevent SQL injection is to ensure that any data that the user can manipulate that you are concatenating as part of an SQL statement is actually from the type you expect. Let's go to our elf chat and click run checks. Elf exploit should tell you that he successfully injected some SQL via the ID parameter of elf.php. Let's open this file in our code editor and look at lines 4 to 5. So if we go to here, go to AC16 and elf.php. Okay, so lines 4 and 5, which are these two. The website takes the ID parameter from the URL and concatenates it to an SQL query as shown below. We can reasonably assume that the website expects an integer ID to be sent. To avoid injections, we can convert whatever the user inputs in the ID parameter to an integer. For the purpose, we will be using the int_val function. This function will take a string and try to convert it into an integer. If no valid integer is found on the string, it will return 0, which is also an integer. To clarify this, let's look at some values and how they would be converted. So 123 as a string will convert to 123 the number. 123 TryAcme will then only retrieve the 123 from the number. If there is no string, it will return 0. this to use so we can modify line 4 of elf PHP like this. So if we go here, we can do int val like this, I think. Yep, int val. That way, even if the attacker sends an SQL injection payload via the ID parameter, the app will try converting it to an integer before concatenating it as part of the SQL statement. The worst case scenario, the string gets converted to a 0, which is still harmless in this particular case. Make sure to press Ctrl S to save the changes on the document and ask the elves to recheck the app. This time, elf exploit will again tell you he can inject SQL, but in a different way. This happens because the ID parameter is used twice in elf.php to form two separate SQL queries, one to get the elf's information and another to get any toys built by them. Find where this happens and fix the vulnerability. Once you do, ask the elves to recheck, and if your fix is correct, you'll get the first flag. Okay, so we'll go here and... okay, so there's apparently another ID, which looks like here, so what we'll do is int val right there. So now let's run and see if it's all fixed. Apparently there's somewhere else where it's not working. Something that I might try is, instead of using the ID parameter for getting the toys, what we could do is use this elf variable here to get the ID. So what we'll do is grab this and we will put it here. So we'll do $elf, then it will be square brackets, single quotes, and ID. Let's run that and see if it works. Oh, I need to save it. I think that was the reason why it wasn't working, because I forgot to save before. Now that's worked, we've got the first flag, so we can copy that and paste it in. Okay, so let's go to the next part. Fixing SQL injection using prepared statements. While in some cases you may secure code with simple validator, there are situations where you need to allow the user to pass arbitrary strings through a parameter. One example of this can be seen in the search bar of our application. Every time a search is done, it gets sent to search toys PHP via the Q parameter. If you ask the elves to recheck the application right now, elf exploit should have a way to take advantage of a vulnerability in the parameter. If we open search toys.php in our code editor, we can quickly see that a query is built in lines 4 to 5. So let's go here, let's go to search toys, lines 4 to 5 here. So it's getting Q. Here the Q parameter gets concatenated twice into the same SQL sentence. Notice on both cases, the data in Q is wrapped around single quotes, which is how you represent a string in SQL. The problem with having PHP build the query is that the database has no other option but to trust what is being given. If an attacker somehow injects SQL, PHP will blindly concatenate the injected payload into the query string and the database will execute it. While there are a couple of ways to go about this, the safest bet is to use prepared statements to prevent SQL injection. Prepared statements allow you to separate the syntax of your SQL sentence from the actual parameters used on your where clause. Instead of building a single string by concatenation, you'll first describe the structure of your SQL query and use placeholders to indicate the position of your query's parameters. You will then bind the parameters to the prepared statement in a separate function call. So instead of providing a single SQL query string, we'll send any dynamic parameters separately from the query itself, allowing the database to stick the pieces together securely without depending on PHP or the programmer. So first we'll modify our initial query by replacing the parameter with a placeholder indicated with a question mark. This will tell the database we want to run a query that takes two parameters as input. The query will then be passed to the MySQLi_prepare function instead of our usual MySQL query. MySQL prepare will not run the query yet, but will indicate to the database to prepare the query with a given syntax. This function will return a prepared statement. So let's copy this and we will put it in here like so. Save that. To execute our query, MySQL needs to know the value to put on each placeholder we defined before. We can use the MySQLi statement bind param function to attach variable cell placeholder. This function requires you to send the following function parameters. The first parameter should be a reference to the prepared statement to which to bind the variables. The second parameter is a string composed of one letter per placeholder to be bound, where letters indicate each variable's data type. Since we want to pass two strings, we put SS in the second parameter, where each S represents a string type variable. You can also use the letters I for integer or D for floats. You can check the full list in the documentation. After that, you'll need to pass the variable themselves. You must add as many variables as placeholders defined with your question mark in your query, which in our case are 2. Notice that in our example, both parameters have the same content, but in other cases it may not be so. The resulting code for this will look like this. So we'll grab this, and we will put it just below there, and save it. Once we have created a statement, and bound the required parameters, we'll execute the prepared statement using MySQL statement execute, which retrieves the statement and as its only parameter. So let's copy that and put it below, save it. Finally, when a statement has been executed, we can retrieve the corresponding result set using the MySQLi statement getResult, passing the statement as the only parameter. We'll assign the result to the toys_rs variable as in the original code. So let's copy this and put it here. So let's now run it. So flag 2, we'll put that in here, submit. Oh, my bad. Okay, now submit. So as you can see here, there's an issue with toy.php. So we'll now go through that and figure out what the issue is. So it seems to be the same thing here, where it's getting the ID, and for this one, we can do the same as the first one where we're doing the interval. So let's paste that in here, and Control S to save, and say run checks. So that hasn't fixed toy.php, so let's see what else is the issue. The same thing down here, so int val, and put parentheses around it, Control S to save, and now let's run it. Okay, there's still an issue with it. Okay, I think we'll need to add some parameter stuff to it, which like we did in search toys. So let's copy where we can. So we'll grab this key one. Okay, actually I will zoom in so we can properly see stuff. We'll go to the elf.php toy. So we will have ID, and we are retrieving ID from the get. Well, let's build the query first, so we'll paste that here. So the query is select where ID equals question mark, like so. We can get rid of this, we can get rid of this as well, and we will paste this under here. So I think it said I for ints, and then we'll do $ID, and we can copy these two lines, that's fine, and like that. So wherever it is that we're doing this get right here, we will put the ID variable there as well. So let's run to see if that's all good. Okay, so there are no vulnerabilities, but apparently something's not working correctly. Let's undo some changes, see what went wrong. This is ID get. So Control Z to undo, Control Y to redo. Okay, we're gonna do the same thing here as well. So we're gonna copy all this and go to here, paste it in, but we need to modify the query so it's this into here, so that equals question mark. So I've already got the ID, so I don't need to redo that. Got this all good. Then it's kids_rs, so we'll put that here. Okay, let's save, and let's run the check again. Apparently not working. Select $sign uses ID equals. Okay, so that's just not working at all. Okay, I didn't take a proper look at this. We need to get rid of these $sign stuff. Then we need to do int val, like so. Now hopefully that works correctly. Okay, cool. We've now got flag 3. Paste that in, submit. Now onto flag 4, which is on login.php. So with SQL injection in the username, if you want to try it, just use any password for this and that. Seems that sending the user and password via post, so we want to search for parameters sent using the post array instead of get. So let's see how this query is built. So select $sign from users where username equals this. So it's going from the post, getting the username, and it's doing this. So it'll be same thing again about doing the parameter type stuff. So we will just we'll just copy all this. We will paste it above, and then we'll modify the query. Select from users where username equals question mark and password equals question mark. So we'll remove this. So get statement. I've already got the username, password. So this is SS, this is username, then it's password. I think that's what it looks like when you do yep, that's all good. So running it, we want users_rs to be the name, and we will delete this. So let's save and run it, and that is the 4th flag. So that is now the end of day 16 of Adventure Cyber. If you like this video, make sure to like and subscribe.